Go.
So James with Love My Pups, My Breeding Supply. A lot of people ask me about coat color genetics, specifically in French bulldogs, and how does this all work. So I'm going to do a quick video. It's a pretty complicated subject, and I'm not a geneticist, so I won't get everything 100% right in terms of the details, but we're going to get everything that matters in terms of why you get different coat colors and Frenchies and how you can go about deciding what those might be. So the first thing is that every cell in every animal's body has some genetic material in it. They're called chromosomes, and chromosomes are made up from strands of DNA, and this is this little spiral of proteins that decide exactly what makes up this animal. So this little piece right here, I'm not going to get into this for very long, it's basically two spirals of DNA material. And they kind of spiral together like this. They kind of twist together in a spiral. And there's proteins that link across them, and those proteins decide, that's the kind of the genetic code. So what happens is when this creature mates with another creature, they make a baby. And what happens is their DNA splits, and the DNA from one parent combines with the DNA of the other parent to make this new creature with its own DNA material in here. So this offspring from these two parents is kind of a mix of the two. It's 50% of one and it's 50% of the other. But it's not exactly, you don't know which 50% they got. That's why every single creature on this earth is genetically different than all the rest. That's why if you commit a crime, they can look at your DNA, and from that they can decide if they can find DNA material whether you were on that crime scene versus somebody else in the whole world, like billions of people. So we're all unique in this respect. All right. So there's a lot more about the whole genetic thing. I don't want to go into, I'll spend the whole time talking about that, but I just want to get the point across that every cell in your body has this DNA material on it. This DNA material is made from double helix. Half that helix and half the helix of the other parent produces the new offspring when they mate, and that's what decides what that animal is. So that's where this information comes from. It's the DNA. All right. So let's talk about. Let's just talk about one particular trait to start with. Let's talk about the blue trait in Frenchies. It's actually called the dilution gene. It's not really a blue gene. It's called a dilution gene. But the whole point is that there's, in just about all these genes, you've got two varieties. You can either have it or you don't have it. So when we start talking about blue, the dilution gene, that's a dog that is big D, does not have any blue genes in it at all. It got one of these from one parent and one from the other parent. That's that double helix we're talking about. So what are the possibilities? Well, this parent could have given them the dilution gene. It's always written as little d for a recessive gene, and the other parent might not have given them the recessive gene, or both parents gave them the recessive gene. And if you are going to be a blue dog, you have to have two copies. You have to be little d. This is a dog that is blue. This is a dog that is not blue. And this is a dog that isn't blue but can have blue puppies, and we'll find out why that is in a moment. So this is the outward appearance of the dog, is its phenotype, but the genetic makeup of this dog is a genotype. This is a non-blue dog, both phenotype and genotype. This dog is a blue dog. It looks blue, so it is genetically blue, and phenotype, physically it looks blue. And this dog is physically doesn't look blue, but genetically it's capable of having blue, having blue puppies. So this genotype is a blue carrier, but it doesn't look blue. All right, enough of that. Let's get rid of that. So now we're going to get into the specifics really quickly and the actual colors that you can have in a Frenchie. But I want to talk about a punnett square, or punt square. This is the way that geneticists look at what you can get when you put two dogs together. So we're going to look again at this blue situation. So remember, the dog can be DD, doesn't have any blue. It could be little d, recessive blue, it is blue. or it can have a copy of blue. So it's got one parent, and that can be written two different ways. This parent didn't give blue, this parent did, or the other way around. Could be like that. They're genetically exactly the same. Those are the four possibilities that you could get where you put two dogs together when you're looking at the blue trait. So there's a thing called Punnett square, and what that is you look at this way. You say this is parent number 1, this is parent number 2. And of course this might be a male, then that's a female. We don't care, it doesn't matter about sex, we're just talking about colours here. So, this dog here, let's pretend that this dog is DD. It's this dog right here. It's got two copies of non-blue, and the other parent is a blue dog. It's DD. So now you go to this square to decide out what all the combinations of what you could get out of these dogs. So right here, this one and this one combine together, and that becomes that. This one and this one come together, and that gets that. This one and this one come together, and that gets that. This one and this one gets together, and that gets that. And guess what? All four of these dogs are not blue, but they all carry blue. They've all got a copy of blue. So, although these dogs don't look blue, guess what? They actually can produce blue dogs. Let's find out why. Let's take these two dogs and we'll make these two dogs together. All right, so we'll do another Punnett square. So we've got big D, little d. On this side here, we've got big D, little d. So what happens? This one and this one combined, that gets us a non-blue dog. This one and this one combined, that gets us a blue carrier dog. This one and this one combined, that gets us another blue carrier dog. This one and this one combined, look at that. There it is. There's the blue dog. So out of 4 dogs, 1/4, a quarter of the dogs would be blue, on average. 3/4 of the dog would not look blue, but in fact 2 of those 3 would actually have a blue gene and be capable of producing blue dogs. So this little square lets us look at things. All right, enough of that. Now let's go look specifically at Frenchies. And let's see what's going on. And then Russ here is taking the video. He's going to start asking questions because he is new to this as well. And I think it's helpful if somebody who's not quite sure what's going on asks questions, because you'll probably have the same questions. So let's talk about the various different loci. Loci are the places on the genetics of an animal, on their chromosomes, that define various traits. The length of their hair, the color of their eyes, how tall they are, how big they get. They're all in the DNA structure. But the specific things we want to look at are, in a Frenchie, is it blue? Is it chocolate? Does it have brindle? I'm going to go over here. Is it cream? Can you read this okay, Russ?
Looks okay.
Is it cream? Does it have 10 points? Does it have a black mask? And let's go over here for the last one. Is it Merle? All right. Those are pretty much what we're looking at in a French Bulldog. So what we're going to do is we're going to put a bunch of letters together, and those letters will tell us what that dog is. So I kind of out of order here a little bit, but it doesn't matter. But let's just write underneath these what the genes are. This is the B gene for brown. This is the D gene for dilution. Dilution in blue in a French Bulldog is actually a muting of a color. It's a dilution gene. E is the cream gene. M is the Merle gene. KBR is the brindle gene. And this one is actually 3 things together. It's either AY, it's either AT, or it's A. And the black mask is EM. So those are the letters that we use to define what a Frenchie is. And this is a little confusing because actually to get a blue dog, it's got to be DD, little d's. To get a cream dog, it's got to be EE. To get a Merle dog, it better be one of each, otherwise you get problems with blindness. We'll talk about that here in a little bit. The chocolate dog would be BB. The brindle dog can be just one copy of KBR. The other one that you get is KY, not brindle. Just one copy of brindle makes it a brindle dog. Then EM, one copy of EM can make a capital EM, makes for a black mask. And this goes in hand with this gene here, and we'll talk about that here in a bit. This one is a tan point. This is a fawn dog. This is a tan dog, and this is what's called recessive black. We'll talk about that here in just a little bit. All right, so let's excuse me, I got a cough again today. Let's put some stuff up on the map on the board here, and let's just decide what these dogs might be. So let's talk about. Let's go with a dog that's got everything. So here's a dog. It is B, B, D, D, E, E, K, Y, K, Y, A, T, A, T, M, M. Yeah, we just written down a dog. What the heck is that dog? So, all right, Russ has been learning a little of this stuff. Russ, what does that mean?
Okay, so BB would be, it is a chocolate.
It's a chocolate dog. If you only had one copy of B, it'd be a chocolate carrier. It would not look chocolate, but it is a chocolate dog, correct. So it's chocolate. Very good. Chocolate.
DD would be your blue or delusion.
Yes. So is this a blue or blue carrier or a non-blue dog?
That's both. It's a blue dog.
It's a blue dog, correct. So it's blue. So this is a chocolate blue dog. By the way, if you get a chocolate and a blue dog together, that is actually a lilac dog. Okay. EE.
The EE is a cream.
That's right. 2 copies of EE makes us a cream dog. So there it is, cream. Cream's a bit funny, because if you get 2 copies of EE, it's a cream dog, and it's like white paint. It covers everything else up. All these other things that we normally see, it just looks like a cream dog. So cream is a bit funny. It physically wipes out everything. It's there, you just don't see it because it gets covered up with white paint. So this is now becomes what's called a platinum dog. If you have all of this together, we call that a platinum. So another way you might call that a lilac covered in cream. Is the other way to call that, because the covered in cream part means it just looks cream. Actually, you'll see some variations in its nose and its pads of its feet and its eyes. They'll all look different in a platinum dog versus a cream dog. So you can tell this dog normally, but anyway, it is a cream dog. All right. KY, KY.
So KY has more symbols than the previous 3 that we looked at. We got a KY, KY. So I'm just going to guess that is a. If you got 2 KYs. You got a brindle?
No, KBR is the brindle. So 1 or 2 copies of KBR produce a brindle dog. If it doesn't have any of this KBR, it's a KY, and it's not a brindle dog. This is a non-brindle dog. This is not a brindle dog.
Does it have a carrier? Can it produce a brindle dog?
Nope. Well, we'll talk about that here in a moment. Nope, that's a non-brindle dog. It can't contribute towards producing a brindle dog. It could be put with another dog that's got brindle and produce brindle puppies, yes. We haven't talked about this, Russ, so this is the tan point gene. So this is ATAT, this is a tan point dog. It'll show tan points. MM is a merle. This has got 1 copy of merle, and that's all it takes to produce a merle dog. So this is a merle. And by the way, the merle gene, you don't want to have 2 copies of merle. Merle is the actual merle part. This is a non-merle. You don't want to have 2 M's together. If you do, you will probably have blind dogs, deaf dogs. You never put a merle with a merle. You never put a merle carrier with a merle. You always put a merle with what I would call a merle carrier with a non-merle dog. You don't want to produce 2 M's here. It'll be a disaster for you.
So this is kind of a change up too from the BB, which was a chocolate. They're lowercase BBs, but on this merle, the dominant is the capital M instead of being a lowercase m.
Yes, exactly. Yeah, exactly. Yeah, it's kind of a bit confusing, isn't it? So there's something else we didn't put in here. Was the black mask. So it's funny how this works. These 2 work together, these E's and EMs. If a dog's cream, it can't have a black mask. So there's some reasons for that. I don't want to go into that now, but basically this dog can't have a black mask because you can never have a cream mask, a cream dog. It's EM, EM.
But it can carry the black mask?
No, not as a cream dog, because the problem is these are all in the same locus. It's either an E or it's either an EM. So the combinations that you can have are little e, EM, little e, that's the cream dog, or EM, EM, 2 copies of black mask.
So the same slot in the DNA is held by or used by both black mask and cream, and only one of them can be in it at any particular time?
Yes, kind of, yes. And again, I don't want to get in the nitty-gritty of this because I will start getting off topic and we'll start getting into some detail. But yes, that for various reasons, it's like to the best of my knowledge, you cannot get a tan dog that has brindle. Now, there's some reasons for that. Again, I don't want to. But if you ever see a tan dog, you know it doesn't have brindle. All right. So anyway, we've pretty much described what this dog is, right? So now that we've got this, I'm going to wipe this out. And we're going to breed some dogs together. So we've got a dog here that really has got just about anything you could have genetic-wise in a recessive form. It's got everything. So let's say that you wanted to produce a blue dog with this. If you bred this to a dog that had DD right here, then all the puppies would end up being DD. They'd get this from one parent, this from the other parent, they'd get that. Is that a blue dog?
No.
It's not a blue dog. What is it?
It's a blue carrier.
Very good, Russ. All right. That's exactly right. So you will not, if you put this dog, which has got everything, with this dog that's got capital D, a non-blue dog, you are not going to get any blue puppies. Those puppies could produce blue puppies in their next generation, but they will not be blue in this first generation of puppies.
So to produce a blue, both dogs must have at least a carrier, or one of them must be pure blue.
Very good. So let's talk about that. So if you put these two dogs together, this is the blue dog, right? Actually, in our case, the platinum, but it's a blue dog, and you put it with a blue carrier dog. What do you get? And the answer is that you get some DDs, and you get some DDs.
So 1 chance in 4 of having a blue dog?
Actually, it's 50-50. It'd be 50-50. If you do the Punnett square on that, you'll find it's 50-50. Half the dogs will be blue, and the other half will be blue carriers. So the answer is, if you want to get a blue dog out of this, you need to, at the very least, have had that in the genetics of that dog. Better yet, if you want them all to be blue, you put that in it. Same thing happens when it comes to the chocolate. If you marry that dog to this dog here, what does it produce?
Marry which dog? The blue with
this
the chocolate?
This dog here to this dog here. What is this dog?
So that's not a blue.
It's not a chocolate.
It's not a chocolate.
Not a chocolate.
But it is a blue. So
we're in this. It's confusing. B is brown. So we're done with that. We're talking about this over here. So this is a chocolate dog married to a non-chocolate dog. Right.
There's no way you could get a chocolate out of it?
That's right. It's not going to get chocolate. You'll get chocolate carriers, won't you? Every single dog will be this. Every single dog will be that. Every single dog will be a chocolate carrier. But none of them will be chocolate.
And that's because if you put it in the pundit chart, not because of it, but the pundit chart describes what we will get.
Very good. So let's just do that real quick. So here's the one. Here's the other. And look at this. Get that. Get that. Get that. Get that. Every single dog is that. They're all dogs that can produce chocolate puppies. They're all chocolate carriers, but none of them are chocolate.
So what would we have? We don't have a blue and we don't have a brown.
Well, let's just go back and just put this in here and we'll make this change this. And let's say that this is BB and this one was DD. And let's just say the offspring we produced in this case were BB and DD, which they would be, right? Mm-hmm. They're not chocolate dogs. They're not blue dogs. Now, let's go to this one right here. What do you want to marry it to? If you marry this to the dog that does not have cream, then these are all cream carrier dogs. None of them are cream. And if you put this to a dog here that has one copy of brindle, then you will get KBR, KYs, one copy of brindle shows up, or you get KY dogs and they won't be brindle at all.
So if you mix a brindle, a KBR, with anything, you're going to get a brindle. It will end up being a brindle.
So let's go to the pundit on that. So the problem with brindle is, and I say the problem, lots of people love brindle dogs, so I don't want to kind of pee on anybody's post-toasties here about brindle dogs. But brindle is a dominant color and it shows up really quickly. It just takes one copy for it to show up. So if you have a dog that is KY, no brindle, and you marry that to a dog that's KBR, KY, what do you get? Well, you get KBR, KY, brindle dog, KBR, KY, brindle dog, KY, KY, non-brindle dog, KY, KY, non-brindle dog. Half the dogs are brindle, the other half aren't. If you'd made this a double brindle dog, then this row here turns into KBR every time, KY, KBR, KY. Every dog has a copy of brindle, and every dog probably shows it. You don't take any brindle at all, it normally shows up. It may not show up when they're born, it may not show up till they're 4 weeks old, but it'll be a brindle dog. So that's the problem with brindle. Brindle is more, there's a lot more brindle dogs out there because it's a dominant colour, and because of that, supply and demand, there are less non-brindle dogs, and non-brindle dogs typically, people seek those out more. Unless you're in a show ring. I mean, the show ring brindle dogs do very well, but people who are breeding for colour, and there's lots of you who are looking at this and saying, hey, he's a complete idiot, why is he breeding for colour? That's not what we're talking about today. If you don't like the colour, then hey, I understand, but a lot of us do breed for colour, and so we typically would rather keep the brindle out of it because it messes things up. Alright, so let's keep on going here. Alright, the tan point gene. So to get these tan points on a dog, where its forearms, above its eyes, its cheeks, its butt, have this different, much lighter tan colour, you need to have the AT gene present. And you need to not have the KBR gene. The KBR gene wipes this out, not because it physically doesn't make it happen, but what happens if you look at a hair on a dog, if it's brindle, the brindling is bands of colour, like this. And that makes it this brindling look. A tan point dog only has it on the end. If you marry those together, you get a dog that's brindle and tan point, and you can't tell the two apart. It gets muddled in it.
Now, are you describing a hair, or
Yes.
are you describing
Yes.
somewhere on the skin?
No. So I'm sorry. I'm describing the hair itself. I'm sorry. Very good. So yeah, this is a strand of hair on the dog, right? That's a strand of hair, and that strand of hair, if it's a brindle dog, it has bands in it. It's banded all the way down the length of the hair. And it may be lots of banding, it might be hardly any banding, that just depends on how much brindling shows up. But the point here is, if you want to produce a tan point dog, then you want a dog that just has this basically one band on the very tip, and you don't want it here, and this messes it up. They combine together on the hair, so you get both things happening at the same time, and it all gets muddled up. The tan points are there, they just don't show up very well.
So when you say tan points versus the brindling, is there a particular color that makes up?
Well, you can get blue and tans, black and tans, chocolate and tans, lilac and tans. Anybody who knows much about this, you're asking a question that these people who are looking at this probably know the answer to. But basically, the tan point dogs are dogs that look like Doberman pinchers in their colouring. They have this colouring on their forearms, on their cheeks, above their eyes, and typically on their butt. It's a lighter colour, tan points. To get the tan points to show, you know what? There's two ways you can get tan points. You can do AT, that works fine, or you can do ATA. Both of those will produce tan point dogs. If you produce a dog that is AYAY, that's typically a fawn dog. AYAY is typically a fawn dog. If you produce a little a dog that's double recessive, what it does is it makes the whole coat uniform. So these are kind of modifiers. Again, I don't want to get too far into this, but this is a desirable thing. AT, in my opinion, is desirable. ATA is desirable. AA is desirable. These things here don't make the tan point dog. So if it depends on what you're trying to do as to whether that's desirable or not. But most of my dogs have a copy or copies of A's and ATs. Okay. So I hope I haven't got people too confused. There's certainly more here that I can put down in 5 or 10 minutes. But the point here is that you can have a dog that doesn't look blue that can produce blue puppies. You can have a dog that doesn't look chocolate that can produce chocolate puppies, doesn't look lilac can produce lilac puppies. And the answer to that is it has to have one copy of the recessive gene present in both parents, because in that Punnett square, when you put these two things together, like the non-chocolate dog, do it right, the non-chocolate dog bred to the non-chocolate dog, there's one square in a Punnett where you get the two recessive genes together to produce that particular trait. There's your chocolate dog. All the rest of these will not be chocolate dogs. It's the same with any of this stuff.
Now, in the past, I've heard you describe a dog's eyes will glow.
So that's another separate thing. One of the problems is, how do you prove what you've got here? If you say you've got a chocolate dog, how do you prove you've got a chocolate dog? Well, one way is you've got two chocolate parents. Trouble is that some of these things, like chocolate, you cannot test for. There are some testable chocolates, Isabellas, in the Frenchie world that just now kind of getting in there in the last couple of years. But in most cases, you cannot, if you send off for a genetic test on a dog, it will come back that it's not a chocolate dog, despite the fact that it is. And in my experience, and I've had a lot of it, every single time I've had a chocolate dog, its eyes glow red, in a completely dark room, taking a video with your smartphone, its eyes dark red. Doesn't show up when they're first born, because their eyes aren't open. When their eyes are open at about 10 days, you might see a little bit of it. It becomes a lot more dramatic when they get to be 4 or 5 weeks old, then you can really see it. So guess what? A lilac dog, which is what? A lilac dog is a chocolate dog and a blue dog combined, will have a red eye glow. A chocolate dog will have a red eye glow. A dog that is a chocolate carrier will not have a red eye glow. So there gets to be the problem. If you've got this chocolate carrier dog, and somebody says, well, the dog might carry chocolate. Well, the problem then is you don't know whether it got it or not.
But both will glow.
No,
Just
only the one that closes. You've got the double recessive, both copies of it, to get the red eye glow. So here's an interesting thing. So let's say that you have a chocolate chocolate dog that is bred to a chocolate dog. So what do you get? So you get the big B little b. That dog doesn't have red eye glow. This dog is chocolate, has a red eye glow. This dog is a chocolate carrier, doesn't have a red eye glow. And this dog is a chocolate dog, does have a red eye glow. But you know that both of these puppies have the chocolate gene because that's all the mum could have given, that's all this parent could have given out. You don't have to say, hey, I can't test for it. You know categorically that that is a chocolate carrier dog because it had a chocolate parent. If it had a chocolate parent, it has to have at least one copy of chocolate. It's either a chocolate dog or it's a chocolate carrier. So this is the one situation when someone can say, I've got a chocolate carrier dog, and you can prove that it really is a chocolate carrier dog.
So you could have a platinum that's eyes glow?
It will always glow. Yeah, platinum is a chocolate dog. Eyes will glow. A blue dog, any dog that has little b, its eyes will glow. Always in my experience, always. People are going to tell me that I'm wrong. I've never seen it being wrong, and I'm talking about hundreds of dogs. Never seen it not work. And I've never seen a dog I've never seen a red eye glow. Well, I don't know about Merrills. Merrills are a bit different. They may have red eye glow. I'm not sure about the Merrills. I'm not experienced on that. But I can tell you this, anytime you have a red eye glow, and a non-Merrill regular Frenchie, if it's got a red eye glow, a proper red eye glow, then that's a chocolate dog. All right. I think that's enough to get started. I think we're going to put that video up and see what my reaction to it is and see if people want more or not. The problem with all of this is there's quite a bit to it, and it certainly can't be explained just in 5 minutes. But I think that's a starting point. So James with Love My Pups and My Breeder Supply, make some comments if you want more information on this, and I'm going to do it. If you think I'm an idiot, well, tell me that too. Thanks for watching. Bye.